Simple exercise on how can we distinguish between alkanes and alkenes. Let's look at the question 1. It says here, given below are the structures of 4 hydrocarbons, A, B, C, D, and explain why all 4 compounds are hydrocarbons. Yeah, your answer would be, you see, all those compounds, it contains only hydrogen and the carbon atoms only. You see, all of them contains carbon and hydrogen atoms only. So they are a hydrocarbon. So they're all hydrocarbons. That's question 1. Question 2. And you are going to classify the compounds A to D as either alkanes or alkenes. And you write down the molecular formula. So for A, how are you going to write it? For A, you see here, is C4, H8. See here, C, 1, 2, 3, 4. And hydrogen, 1, 2, 3, 4, 5, 6, 7, 8. So that's A. Okay, that's molecular formula for A. Now B is C4, H10. If you count, that's 10. Now C is C2H4 and D will be C3H8. See, that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's the molecular formula for each of those. And they are asking you whether it's an alkane or alkene. Of course, this is an alkene. A is an alkene. C is an alkene. That's alkane, alkane, because that's single bond. Next one. Now, if the general formula for alkane is CnH2n plus 2, what's the general formula for alkene? Now, it's CnH2n. That will be the general formula for alkene, because it's carbon-carbon double bond. Now, next one. They're asking you to classify the compound below, whether it's an alkane or alkene. See, that's CnH2n plus 2. You see, because that's 8. Okay, so that is definitely alkane family. That's an alkane family. And this one is CnH2n. Can you see it's doubled? And that's an alkene. And that one, that is a alkane, because it's CnH2n plus 2. And that one is CnH2n. That will be alkene. And this one, again, that is an alkane because it belongs to CnH2n plus 2. Okay, so that's how you tell. Next one, they're asking you, say, how do you distinguish alkanes and alkenes? Using chemical reaction. Now, combustion means burning. So they both burn well because they both good fuels. So if you're using burning, may not be the best way, because alkane, for instance, if you say CH4, that is an alkane, that will burn and then produce carbon dioxide and water. So that will burn very well anyway. So they both burns. So that's 4 hydrogen, that's 2, so I put 2 here. That'd be 2 times by 2 is 4 hydrogen, and that gives you 2 oxygen here and 2 oxygen here. That makes 4 oxygen, so I have to add 2 here. That's 1 carbon, 1 carbon. So combustion, burning, for alkane, they release carbon dioxide and water. For alkene, the smallest molecule has to be 2. If I write 2, C2H4, again, it's burning in the air. It will also produce carbon dioxide and water. So the main thing for burning is to produce energy. So this is a byproduct, but they are not balanced equation. Let's say this is 4 hydrogen, it's only 2 hydrogen. I add 2 here, 2 times 2 by 4, that's 4. And that is 2 oxygen plus this 2 is 4. So, but I have a 2 carbon, so I have to have a 2 carbon here. That makes 2 carbon. So oxygen will be 2 times 4. 4 plus this is 2 is 6. So I have to add 2 times by 3 is 6. So that's balanced equation. However, the burning, combustion, they both produce carbon dioxide, water. So it's not a good way to tell which is which. But if I'm doing bromine water, that will be great. For instance, bromine water for ethane, because it's double bond C2H4, and if I have a ethane, then I add bromine water to this compound. Then what happens is that this double bond is broken, and this 4 carbon still there, it has not been lost. So I'm going to have these 4 carbons written here, and each of those is going to be bonded with a bromine. So that is bromine water. This orange color disappears because this is reacted with ethane. So that is a colorless compound, and therefore this is bromine decolorized. That is a very good way to tell which is which, because if I have a ethane, for instance, in this case it's carbon-carbon single bond. If I have ethane to react with bromine, and then you shake, you won't decolorize bromine water. There is no reaction, so the color still remains, and therefore that's how you tell which is which. Okay, next one. Which of this is a better way? Yeah, which of this test is a better way to tell which is which? Of course, it's adding bromine water, and because it gives you distinct color change. Question 7 says, complete the following true or false statement about alkene. Let's look at this. It says here, all alkenes are hydrocarbons. Yes, all alkenes are hydrocarbons. That's correct. The olin contains hydrogen carbon atoms only. And their general equation is CnH2n plus 2. No, the general equation should be CnH2n rather than that. That's alkane. Okay, next one. Ethene is an alkene. Ethene is an alkene. Yes, that's true. Now, alkene decolorized bromine water. Correct. Olin alkene is able to decolorize bromine water. Use these words is the best way. Don't say it turned clear. That may not be accurate. Now, C4H10 is a alkene. Now, C4H10 belongs to this general equation, CnH2n plus 2. So that's for alkyne. But it's not alkene. So that's wrong. It is wrong. Next one, alkene burns with a non-smoky flame. And alkene, it depends. Alkene, if it's a long chain, now might be a little bit smoky, but its short chains will be quite clean. So it depends. So it's not quite clear. We need to look at that carefully again. So it's not quite accurate. Last one, the formula C4H8 represent alkene. It is represent as an alkene because it's CnH2n. Okay, I hope this helps you to revise alkane and alkene family. Okay, thank you very much. Bye.